Now we're going to get down into the serious business of solving an equation by completing the square. We have arrived. So my whole purpose, now I'm going to try to investigate what I'm going to do here, is I start off with a quadratic equation, maybe in the form of ax squared plus bx plus c is equal to 0. What I'm going to do is I'm going to complete the square. And when I complete the square, it is going to have the form x plus h, close brackets, squared is equal to k, where h and k are just simply numbers. When I have that, I'm able to take the square root of both sides. And when I take the square root of both sides, don't forget to include the plus and minus the root of k. Last step is I'm just going to subtract the constant h, and we will have solved for x. So there we have it. So we have an equation. And remember the 4 commandments to maintain equality. Undo what is done, inverse operations. We will not be doing that. We're not going to be multiplying by 1. You can, but we won't. We're not going to be adding by 0. But what is really often used with equations is what we do to one side, we do to the other side. So here we have it. I'm going to call this an aside. And this is my, if you want to call it, my junk work to help me solve this equation. This is the work that I do to the side to support my answer. So first things first, I need to complete the square. So I am just going to add 2 to both sides. So in red, I'm just going to call this add 2 to both sides. And in black is going to be the overall theme is I'm going to isolate the x's. So put the x's on one side, constant on the other side. Now that's all good and dandy. So I'm just going to call this step 1. Step 2, I'm just going to rewrite this. And suspiciously, I leave a big blank right beside 8x. And over here, I'm going to complete the square. So in red, what is my specific to the question and the process is I'm going to complete the square. So now I'm going to complete the square. I'm going to add a constant to x squared plus 8x so that it creates a perfect squared trinomial. So allow me to do that. I take a look to complete the square. I take a look at that 8, and I take 8 and I divide it by 2 and I square it. 8 divided by 2 is 4 and I square it. And that is equal to 16. So to complete the square, I add 16 to both sides. And in general, to complete the square, we take the b coefficient, divide by 2, then square. Step 3, I'm going to choose to factor it. When I choose to factor it, x squared plus 8x plus 16. If I factor that, the left-hand side factors into x plus 4 squared. The right-hand side is 18. Now, you may be wondering, like, wow, you factored that really quick. By the way, I completed the square. I knew that the left-hand side was this perfect square trinomial. We are in very familiar territories, so maybe the the theme here is I'm going to factor the left-hand side, right? Perfect square trinomial. So step 4 is I'm going to take the square root of both sides. If you notice, the left-hand side is a perfect square. And I try not to make any thought too big. So I'm going to square root both sides. Last step is I'm just going to subtract 4 to both sides. So specific to this question, I would subtract 4. More generally speaking, I would say move constant to right-hand side, or isolate the x. So there we have it. So to complete the square, we generally isolate the x's. Once the x's are isolated, we need to complete the square. When we complete the square, why did we do it? Because we want to create a perfect square factor. So we factor the left-hand side. Once you have a perfect square on one side and a constant on the other, you square root both sides. You move the constant to the right-hand side. Now, in our previous lesson, we may want to write the equivalent solutions where this would be -4 plus or minus 3 root 2. You can simplify root 18 into 3 root 2. In this course, 5 or 6 are acceptable. All right, next example. Just going to get rid of a lot of this stuff here. So I'm just going to create my rough work here. I'm going to call this my aside. So if I have x squared minus 4x is equal to 5, what I need to do is I need to make sure that this is a perfect square on the left-hand side. So we're just picking it up from a different step. So I'm just going to choose to write it like this. We can, if you notice, my coefficient in front of that x squared is 1. So that is really important. Always double check that, and we'll come into a circumstance where it's not. I need to add a constant to both sides so that the left-hand side is a perfect square. So I take that coefficient, and that coefficient's -4, and I take that and I divide it by 2. And I square it. So that's -2 squared, so it's 4. So the constant that I add to the left-hand side is going to be +4. So if I add it to the left-hand side, I'm going to add it to the right-hand side to maintain equality. So I would say complete this square. That would be my thought here. And complete this square. The next one is maintain equality, because I actually did 2 steps in this line. I added 4 to both sides. Maintain equality. In the next step, I'm just going to factor the left-hand side. And when you factor this, it is x minus 2 squared, and that is equal to 9. So if you want, I could say factor left-hand side. I'm going to take the square root of both sides now. So if I take the square root of the left-hand side, I need to take the square root of the right-hand side. So I'm going to write square root both sides. I find that this is the keystone step to continue on. Because if I have a factored squared is equal to a constant, I know what to do. Last but not least, I'm going to add 2 to both sides. Add constant. Now, I'm just going to write this as x1 and x2 because this really represents 2 different solutions. So x1 is 2 minus 3, which is negative 1. x2 is 2 plus 3, which is 5. So x is going to be equal to negative 1 and 5. So those are my solutions. All right, solving by completing the square. I'm going to maybe go to the more difficult one here. Now, what makes this more difficult? It's that 5. It's an odd number. But we're all going to complete this square, so I'm going to isolate the x's to one side. Oh my God, they're already isolated to one side. So this is my aside. This is my thinking box. So to complete the squared, I need to take that coefficient, I need to divide it by 2, and I need to square it. Now 5 over 2 squared is 25 over 4. Now recall when you square a fraction, it is you square the top and you square the bottom. So I'm going to add 25 over 4 to both sides. Now right about now, people start getting quite concerned. But here, it's the same step, complete the square. So the left-hand side is a perfect square. So I'm going to factor that. Now, I'm going to factor that, and that's x. Well, hold on. Can I ask you a question? What number did you what number did you square? Well, you squared 5 over 2. And interestingly, that is the pattern whenever you want to have a trinomial, a perfect square trinomial, and you want to factor it, the number that you squared ends up being the constant term. So no need to fear fractions overly much. So now that's, the left-hand side is factored, so factor. Now I'm just going to add those two numbers together. 1 plus 25 over 4 is 29 over 4, because 1 is equal to 4 over 4. When we add two numbers, we need to ensure that there's a common denominator. So I could write 1 as 4 over 4 plus 25 over 4. That's 29 over 4. The next thing I'm going to do is I'm going to take the square root of both sides. Don't forget to add your positive and negative root. So I'm just going to clean up the right-hand side because it doesn't look very nice. So when I take the square root of a fraction, take the square root of the top. So square root of 29 it's not a perfect square, so you can't take the square root of it. So it's just the square root of 29. But the square root of 4 is 2. So my answer, now we're very close to the solution, so I'm just going to subtract 5 over 2 to both sides. And there we have my answer. Now, since we're adding and subtracting two numbers with the same denominator, it is generally preferable that we combine the two together. So that is my solution.